Swayam Prabha. Digital India. Educated India.
So, friends, today we are going to discuss about plant layout. If you recollect, in the previous session we talked about the location, plant location. In the plant location we discussed that it is a very strategic decision, because if the factory or the manufacturing facility is located at a wrong place, it will lead to higher operating cost and so many other disadvantages. In the same sequence, layout is also a next level of decision, where we are trying to find out the location of various departments and facilities within the site which has been selected under plant location. So, in that way we can say that plant layout is also a location problem, where we are talking about location of different departments, facilities and other things. Second thing which I want to emphasize here, the chapter is named as plant layout, but here but we are going to discuss various things, rules and regulation, principles, etc., which are equally applicable to office layout, which are equally applicable to warehouse layout or a service center layout like a bank, like a post office, like a restaurant or any facility. So, rather than talking as a plant layout, we can also talk as a facility layout. So, this is there we are talking about the location of various facilities, various departments, various machines, various other utilities in a given place. So, it is related to location of departments, it is physical arrangements of machine. Within the department again it can be further physical location of the machines, and then there can be workplace layout also, where we are talking about the particular workbench or particular workstation itself. So, facility layout means planning for the location of all machines, utilities, employees, workstations, customer service area, material storage area, restrooms, lunch rooms, offices, canteens, computer centers, parking area, etc., etc. For the and it is required for the flow pattern of material and people around, into and within the building. So, we have to see from all perspective that material and people movement into the factory, into the facility, within the facility should be proper, and around the facility also it should be proper. That is why we are talking about the parking area and other areas also. It is planning is for infrastructure services such as delivery of the line communication, energy, water and other utilities, as well as removal of the waste water and all other makeup for basic utilities. So, that way we see that it is a very comprehensive exercise, and this will further govern the operating cost of the system and the efficiency of the system. The improper facility layout may lead to accidents also, may lead to fatigue also, it may lead to poor supervision also. So, in that context we see that, and the space utilization also, you will find that certain places, especially in banks, post offices, the situation is very cramped, and then further start to see that you are finding that the flow of the work is not uniform, people are crisscrossing each other and departments are not properly located, and maybe certain department where the more footfall is there, they are located at the back end of the facility. So, these are some of the things which we are going to study in this particular exercise of facility layout. So, we have to see all the areas in and around building, like equipments, workstations, material storage, rest break areas like canteen, washrooms, restrooms, utilities like generator room, like compressor for compressed air or any other facility, maybe water treatment plant or maybe some other area, canteen, offices, etc. Before going further, let me expose you to one of the factory layout. This is a factory layout of a automobile manufacturing plant, manufacturing two wheelers. Let us say means this is the highway which is going on, and this is let us say the factory. For the sake of convenience, I am drawing it in a very rectangular manner, though it may have not that. So, this is the main entry gate and this is the highway going on in front of it, and there close to this you have to design the parking area. So, first important thing you have to, because visitors are coming or your own employees are coming. So, you have to design the parking area, and on this side maybe a office area, so that your manufacturing facilities are not getting disturbed. And then you will find that in this facility we are having one way here. Here we are having I will give you more about this is our generator room for power backup. This may be compressor, because lot of compressed air is required to for the purpose of assembly. And then there is 3 facilities which are going side by side for the manufacturing of 2 wheelers. One is the press shop, where the sheet metal is given the shape. Then there is a welding requirement, we are having the weld shop to weld the component, and then we are in a paint shop for painting the body, for painting the fuel tank, for painting the other components of this. And then we are having the assembly line here, where the vehicles are assembled, and it is going from paint shop, the components are coming here and going there. And on the other side, if we look at it, we are having the engine plant. So, we can draw the engine plant here. And then we are also having the store area, where incoming material, all component parts are kept here. And there is another gate, there is a road going here also from the highway, and this we call it as a material gate. We can call it as a material gate. All trucks etcetera are entering from material gate, all trucks etcetera are entering from this gate, and this is main for employees manpower. And there you will find that after assembly you are having a finished goods storage area. All the vehicles after manufacturing are stored here, finished goods are kept here, and then outside this we are having the rather than this we can draw the out gate over here, material gate here. So, this is our material gate, and this is where you can have the dispatch area, and here we can have the our steel sheets etcetera, steel yard or something like that, and where we are keeping the scrap also of steel scrap. After press shop, lot of scrap is generated, and we can keep the scrap here. So, like this. So, what you are finding from store, all components etcetera can go very easily to the assembly area, and after paint material can come here, from engine plant material can come here. So, like this, and this is where we are having the plating shop also for some plated components also, and on this area we can have the canteen, central canteen, and then we can have some engineering cell also for the maintenance of the building etcetera, engineering cell etcetera, like this. So, broad layout that will provide you some idea that how the various departments are integrated in the system. So, that there is a unidirectional flow, there is a smooth flow, and all the facility which require the components and part, that is the main in assembly, where these are the jigs on this, where the vehicle is assembled by taking the components from the engine plant, by taking the component from the paint shop, and by taking the components from the bought out store also. There may be certain component which are going direct to the line also, assembly line also. So, this is one layout that I will keep on referring this also in between to just strengthen the various principles and theories for the plant layout. So, what are the objectives of plant? Now, you will get some idea with the help of that particular layout. Efficient and smooth flow of material within the plant. So, we have seen that material flow is unidirectional in nature. From here sheet metal is coming here, and let me change the color here. So, from sheet metal it is going to the press shop, from press shop to weld shop to the paint shop, and paint shop to the assembly area. Okay. And similarly, we can see that unidirectional flow we can see for from material gate to the store, from store to the various assembly areas, or it may also go to the engine plant also, and from engine plant engines are coming to the main assembly area. So, like this. So, efficient and smooth flow of material within the plant, easy access of equipment for maintenance and repair. You will find there is aisle available on all the 4 sides of each department. So, that each and every material equipment can be serviced without any difficulty. fast and safe material handling because of unidirectional material flow. So, it is a safe and handling is also very less, and reducing congestion in the flow of material or worker because of the unidirectional flow, there is no congestion of the material, and cubic space is also nicely utilized. Maximum utilization of equipment. So, we have to plan in such manner that the supply is in one direction and the feeding department is close to the next department. Best utilization of human resource by providing a comfortable and safe working environment. This we will discuss more when we talk about individual workstation layout planning. And then it should have a flexibility for future relayouts also. If tomorrow we want to expand the paint shop, or we want to expand the welding shop, or we want to have one more assembly line. So, there should be provision for that also. And minimum health and security risk, welding area has been kept at one corner, so that the fumes etcetera can go out, and facilitate coordination and face to face communication where appropriate. So, these are some of the objectives which we want to achieve in the plant layout. See now you can see how if you visit some bank, if you are visiting some restaurant, how you feel about that with respect to these objectives, whether the layout of the bank is meeting these objectives or not, or there is some congestion of the people, or the space is not properly utilized. Similarly, in restaurants also sometimes we found that there is a lot of kiosk and other things, it is not properly laid out. What are the symptoms of a bad layout? This is just a reversal of the objectives. Congestion of material, components and assembly can be one of the if you find there is a lot of congestion of material, that is a case that we need to re-lay out the facility. Excessive amount of work in process, that also indicate that machines are not properly arranged and there is a lot of crisscross movement and materials are waiting at different places. Poor utilization of space also, long transportation lines, production bottlenecks and ideal machines. Machines are ideal, on the other side the material is also waiting. This is a very typical situation where the material is waiting to be processed and machines are waiting for the jobs, and that is the inefficient way of operations performance or design of the operations or design of the layout. Long production cycles and delays in delivery, if you find that we are missing the delivery schedules very frequently, that means something need to be done. Mental or physical strains on the worker, if there is a lot of crisis or the worker has to travel a lot for attending to his job, then also it will lead to more mental stress. Difficulties in maintaining effective supervision and control, there is no proper aisle or no proper way to reach to the person or to the machine, that may also affect adversely the supervision. Bottlenecks, congestions and poorly used space, ideal or overloaded workstation. Some workstations are not properly having the proper workload, on the other hand then certain workstations are having more workload. This we will talk more in our next unit on line balancing. We should design the facility in such a manner that all our workstations are having uniform equal workload. What are the factors which we have to keep in mind, or for which we have to collect the data before starting the exercise of plant layout? We have to see the material factors. What is the design of the material? Based on that, we have to see what is the size of the material which we are going to process in that particular facility, or how much variety we are going to have and how much quantity going to be processed. Based on that, we will decide how much space to be kept for the processing, for the work in process material and so on, and that will also decide how many machines are required. Quantity will decide how many working workstations or how many machines need to be installed. Then we have to see the manpower factors, how many direct workers are there who are working on the machine, and how many indirect workers are there in the form of supervisors, material handling people, quality control people and other things. And we have to see also from the manpower perspective that my layout should be safe and machines are arranged in such a manner that there should not be any hazard or safety or accident hazards is there. And then manpower utilization should also be kept in mind while doing the layout planning. Then I have to see the machinery factors, what type of processing machines are required, what are the utility requirements for them, electricity requirement and so other water requirement, compressed air requirement or some vacuum is required or something is required. So, we have to keep that in mind, and then any other type of tooling is required, some other accessories are required, that also we have to keep in mind. Then we have to see the movement factor, that is the one factor which will be very basic thing which we are going to study when we are going to do the layout planning. How much is the movement between the various department, from one department A to department B, what is the type of material movement is there, what type of manpower movement is there. So, based on that, if the movement is very high, we should keep those facilities close to each other. If the movement is not that high, that we can see that they may not be close to each other. And we will use 5 alphabets A, E, I vowels O, U for this purpose, and then X also. A stands for absolute, there is a absolute necessity that the facility should be close to each other. E stands for essential, it is essential to keep the facilities close to each other. I stands for important, it is important that we should keep the facilities close to each other. Ordinary closeness is okay, not much is required, if you can keep it okay, otherwise not. This says that not necessary, unnecessary, there is no requirement of keeping them close, and X is it should be avoided, they should not be kept close to each other, should not be kept close to each other. Just like office area and some heat treatment area or certain press shops where lot of vibration is there, or areas where lot of sound is there, noise is there. So, these should not be kept close to each other, should not be kept close to each other. So, these are the symbols or notation, these are easy to remember also, A, E, I, O, U, 5 vowels and then X. Okay. So, we will use these symbols to see that what type of and these depend, when I say absolute closeness is required, it may be due to the very high material movement, or these processes are dependent on each other, or there may be some utility which is required by them, or any other factor can be there which necessitate that this it should be, it is absolute necessary that we should keep the two departments close to each other. Just like office of the CMD and the committee room. Generally, you will find every CMD office has a committee room attached to it. So, these two facilities should be kept absolute closeness with each other. Similarly, there may be several other cases we will discuss. And then we have to see the weighting factors also, weighting of the materials and weighting of the manpower also, or some other forklift or material handling equipment, etc. Or it can be permanent, means warehouses, and temporary can be in the form of your near to the machines, near to the more like a work in process inventory if there is any. So, how much space I should provide, what should be the arrangement to be made for if the material has to wait for few days or the material has to wait for few hours. So, temporary arrangements and the permanent storage arrangement should be provided. Then we have to say, as I said earlier, we have to provide service factors also, parking lots, washrooms, canteens, waiting rooms, restrooms, tool room, dispatch, maintenance area, etc. They are also need to be planned, need to be kept in mind while doing the layout planning. Then we have to see the building factors also. Building can be single story, it can be double story, it can be multi story, just like hospitals, etc. You will find multi-story hospitals are there, and then they are designed in such a manner, then wards are there, OPD area is there, and operation theatre is there, and other facilities for radiography is there, and other ECG facilities and so many other things. So, they are designed in such a manner that all the floors are equally, and you will observe that OPD is generally kept at the ground floor, because there is large footfall. So, they are kept mostly at the ground floor at the most on the first floor, whereas wards etc. are kept at the higher floors, because we do not want any disturbance to the patients who are indoor, who are admitted there. So, that way you have to see that we have to keep these factors in mind while doing the layout planning. And we have to see the utility distribution also. There should not be too much movement of the utilities also. Then there may be, in case of water, there may be pressure drop, or if it is a vacuum or oxygen supply is there, or some other such kind of a utility is required. We have to see that that is also efficiently routed. Then we have to see the change factors also. If there is a tomorrow there is an increase in production, there is decrease in production, or some more variety is added, or some more design changes are there, or you are changing the material also from metal to plastics, or plastic to metals, or from there is a change in the process also. Then our layout should be versatile, layout should be flexible. We are in a position to re-layout very easily without much cost involved on that. And if there is an expansion need also, that can also be easily carried out. So, these are some of the factors which we have to keep in mind while doing the layout planning. What are the basic principles? Let us see at the basic principles. One is the integration. The most important principle is the integration. The layout should be such that it integrates the man, machine, material and other resources, just like energy, water and other things also. It should integrate. They should not be fragmented, or there is a lot of difficulty in using them. So, we have to keep in mind. Second is the flow. Very important in layout planning. There should be a unidirectional flow, smooth flow, uninterrupted flow. So, for that purpose we have to arrange the facilities according to the requirement of the processes. Then space utilization, you will find many places where the certain areas are highly cramped and other areas are totally not being utilized. So, the space utilization should be proper, and then we have to see here also the third dimension also, the height also. Mostly we do the planning for the surface only, but now we have to keep the third dimensions also by preparing some storage materials, racks, etc. Lot of good automated systems are coming. We have seen the automated systems are there for tooling, etc. In many factories you will find that vertical tower is there, where various types of tools can be kept there, and with the automatic system they can be retrieved very easily. And we have also seen multi-level parking also, where you can park your vehicle at different floors and you can locate also, or it can be automated also, that your vehicle will be automatically parked at the vacant space, like that. So, these are some of the things where you are using the third dimension also. So, that the space utilization is proper. Space is becoming very costly each day. So, we have to be very careful in layout planning that there should not be any wastage of the space. Then we have to ensure the minimum movement also of material, minimum movement of the manpower also, by properly arranging the various departments. Safety and comfort of the employees to be kept in mind. Proper ventilation should be there where more persons are there. If there are certain machines which are generating more heat, or having other factors which can be discomforting to the worker. So, we have to kept that in mind. And then, as I said, one of the important principle is create flexibility, so that the areas of different department can be increased or decreased depending upon the requirement. Many times here I would like to emphasize that there may be some component which you are manufacturing in house. There may be a component which you are manufacturing in house or doing assembly of that in house. Tomorrow you may decide to outsource that component, and the space vacated due to outsource, the space which is vacated due to outsource can be used for the expansion purpose, So, our layout should be such that we should be able to expand the particular department or facility by offloading certain components or parts if the demand of my basic product is increasing. So, within the same floor space I may be able to produce more by outsourcing certain component which earlier I was doing within my own premises. So, flexibility is needed from that perspective also, or there may be some design change or process change also, as I said. So, for that purpose also we need to have the flexibility. As I said that this layout issue is relevant for each and every facility, whether it is a office or it is a retail store or it is a warehouse, bank, post office, hospital, restaurants, etc. So, these are more service oriented things which I am talking about. In offices also you will find that they are arranged in such a nice manner that you are able to and easily locate the office also, properly numbered also, sequenced also, and you can safely pass through the aisle, and the passage should be having the good width also, especially in the I can give the example of schools etc. also. There also we have, when we are planning the classrooms and various laboratories etc., we have to keep in mind the various factors there also, that the children should move from one class to another, from class to laboratory, from classes to playground, and from main gate to the classes in a very safe manner. So, we have to keep in mind, and then the teachers staff area also, and principal's office also, so that there is a good supervision. Principal can see by standing outside the level of discipline, classes being engaged etc., etc., in a very nice manner. Similarly, retail outlets, if you go to the retail stores also, you will find that lot of efforts are being done to provide a proper layout. So, that there are 2-3 different purposes, though we will see at the end also one retail layout planning also, but here at this stage you will find that they place the items which are need to be purchased together close to each other, so that you need not to put much efforts in purchasing. If 2-3 item people are purchasing together, so they are kept in the retail store close to each other. Similarly, there may be some scheme or something on a certain item, they are usually kept at a very near to the gate also, so that it catches the eye of the visitors or the retailers who are entering into a retail shop. Or there may be certain products which are very frequently you purchased, may be kept at some fag end, so that people are walking through the store and looking at various items also while going to the place where they have to purchase the item. So, several such kind of marketing skills and efficient layout planning skills are utilized in the retail shops, and these days big malls are there. So, all such things can be applied there to improve your marketing, as well as to improve the visibility of the product, as well as to improve the convenience of the retailers. Similarly, the warehouse layout very important these days, it is becoming, especially if we look at e-marketing perspective, Amazon, Flipkart etc., they have to design their warehouse in such a manner that now they are talking about delivery in 2 hours, delivery in 6 hours, overnight delivery etc. So, in that context, if you look at it, it's efficient layout, warehouse planning layout, where that will help them in providing that kind of a level of service or performance level, because the volumes are very large, they deal with large volume, and not only that, for the purpose of dispatches or fulfilling the order, when they are receiving the material from various manufacturers, at that time also you have to keep that it's if the warehouse layout is not good, there may be lot of crisscrossing and lot of material waiting to be kept in the racks or in the bins etc. So, all these factors are very important in warehouse layouts all. And then every day we are visiting banks, post office, hospitals, restaurant, airport, and many times we get impressed, oh, layout is very good, it is very convenient to move, and visibility is also there, and you can see the outside whether aircraft has come or not, or so many other features you will find there. So, layout plays a very critical role in giving a good ambience to the service facility and giving a good experience. These days we are talking about user experience also. In design programs, user experience is also very important. It is not only meeting the functional requirement, it also provide a good user experience. When a person is visiting their particular facility, he feel impressed, he feel good about visiting that facility again and again. Now, coming to the more manufacturing driven systems, though these are, I will give you examples, these are also relevant in service systems also, but there are more significances there in manufacturing also, or rather we can say these are pure service related facilities, and these are both manufacturing as well as service related, related systems. We will find examples of in both the areas, in manufacturing as well as in service. One is the product oriented layout. This is usually, as when I was talking about the various types of production system, we said for mass production system we need a product layout. So, we will see that what is product layout and what are the features of that product layout. And then for we said that for batch production and for job shop production we need process layout, because here each product has a different process requirement. So, it is not possible to arrange the machines according to the product, because the quantities are less and each facility is serving several types of products and each product has different process requirement. So, in that case we go for the process oriented layout, and then there is a fixed position layout where facilities are moving and the product is stationary, just like product is stationary and facilities are moving. So, in that case we are using the fixed position layout, especially for manufacturing of aircrafts, manufacturing of in the shipbuilding or manufacturing of flyover, bridges, buildings, etc. So, there also we have to see that for various utilities, various facilities, various equipments which we are going to use, how to locate them. And then there is very important category of layout design, that is called work cell layout, or it is also called popularly cellular layout, where we are whole factory is divided into various cells and each cell is manufacturing one group of items, one group of products or parts or items. So, that way. So, these are several types of layouts or applications of layout planning in different sectors, in different situations. In the offices also means corporate offices, etc. As I said, CMD office, director's office with committee rooms and other their personal staff and so on. So, we have to design waiting area, reception area, etc. we have to design in that case. Now, let us talk about the first type of layout, which is called flow line or product layout. So, you will find in the manufacturing, as I said that the layout is press shop is going to weld shop, and from weld shop we are going to the paint shop. So, this is more like a, because every component has to pass through these three stages. So, we can go for a product layout according to the product requirement. We can arrange the departments, we can arrange the machines also. Secondly, you might have seen the service system also, the vaccination which was done for the COVID. There also you might have observed that it is more a vaccination centers were having a flow line. You go first wait outside, then you go for the registration at the center. This registration is after your online booking of the slot, and after registration you are going for the another waiting area, then you go for the actual vaccination. After that the certificate is issued. After certification issue, there is a again a waiting area or recovery area, where for 30 minutes you were sitting there to see that there should not be any adverse impact or anything any difficulty because of the vaccination. So, that way we can see that it is again a flow line or a product layout you will observe there. And there are several places in the restaurants, etc. also, which are drive-way restaurants. Or at one window you make your order, menu is there, you make your order, make the payment, and then you drive to the other side of the building, and from there you can pick up your order and go out. So, that way a unidirectional flow line kind of a layout can be there. Inside it is like this, like if this is the restaurant and you are driving, this is on the highway or a road, you are entering here and this is the counter here where you are making the payment, you are booking your menu, seeing the menu, you are purchasing the item and then you drive past. And while reaching here you will get the delivery of your contents, food which you have ordered, and then you can again join the highway. Inside the restaurant there may be a process layout. One type of items are manufactured here, another type of items are cooked here, and something is happening different section, and like that there may be a process layout. But from other outside if you look at, it can be a flow line layout. So, though we are studying them as product layout, process layout and other types of layout, but in real life you will find it is a mix of these. Certain departments, certain areas are functioning as a flow line, certain areas are working more as a process line layout. So, it is a combination. For the purpose of understanding we are taking them separately, but otherwise in a real life situation you will find it is a combination. So, applicable to both manufacturing as well as service sector, and so many examples are there around that. We have seen in hospitals etc. also you go from one window to another, registration, then you go to OPD, then you go to the medical store, or if there are some tests etc. are required. So, that can be there. So, what we do here, arrange the machines and or worker in accordance with the sequence of operation for a given product or service. So, because in a mass production, as I said that product layout is used for mass production. Mass production means the quantity is very high and volumes are very high, quantity is very high and variety is very less. So, all the people are having the same kind of a requirements. So, in that case, according to the requirement, according to the process or service, we are arranging it. Like in this case, in a drive-away restaurant, every person has to come here for placing the order and everyone has to get the delivery from here. So, you can have a uniform flow there. Similarly, in the vaccination, everyone has to pass through the same 3-4 stages. There is no crisscrossing, everyone has the same process. So, it is a mass production, mass service, and without any variety, without any customization, without any so large volumes and hardly any variety. One type of process is carried out for each and every job, or each and every product is manufactured according to that. So, in that case we can use the flow line layout. What are the advantages of this? It reduces the material handling. We have seen that if there is a unidirectional flow, the material direction will be very less. Accommodate small amount of work in process. So, there is not much work in process in this case, because facilities are arranged back to back and material move from one facility to another very easily. It reduces the transit times also. So, because facilities are close to each other, so no transit time is there. Simplifies production planning and control systems also, because of less variety, high volumes, hardly any efforts are required in production planning. It simplifies the task and enabling the unskilled worker to learn the task very easily, because the task is repetitive in nature. So, even an unskilled worker can be trained very easily to perform one particular type of a activity. So, that way it is a very highly productive system. Mass production system or product layout systems are highly productive in nature and used where variety is very less. Each job is to be carried out in the same manner. But there are certain disadvantages also. There is no flexibility, because every system has been set up according to a particular requirement. If there is a change and any product coming which has a different requirement, then it may create problems there, or it may not be possible to process that. Then need for the balancing of the line. We will study the next unit as line balancing. If the facilities are not balanced, if the load on the facility, like there are 3 machines in the process and they are to be used one after another, and if they are not balanced, here you need 10 minutes of task, here you are having 15 minutes of task, here you are having 5 minutes of task. You will find that the utilization of this will be very less, maybe only 33% utilization of this, 100% utilization of this, and 66% utilization of this. So, there may be a poor utilization of equipment or workstation stations can be there if the various machines, various workstations are not properly balanced. And there is a large investment in equipment is also required, because the same machine which is required in one line, this is line 1, in line 2 also there may be same machine A, B, C, and there also if we see that in there also there is another line for product 2, there also these 3 machines are there A, B, C, and again you will find the utilization is only 33%. If this has been a process layout, only one machine would have been sufficient to do the process C, but because of the line layout, flow line layout, you have to duplicate the machine in both the lines. There may be worker fatigue also, or worker may get bored also, because same type of he is doing the same type of activity again and again. And there are studies which indicate that worker absenteeism is highest in assembly line areas, in a mass production, in a flow line area, where the repetitive work is there and worker every day he has to perform the same small amount of task repetitively. So, the worker absenteeism is also high because of the boredom in flow line working area. All other factors applicable to mass production. So, the disadvantages and advantages are same as it is for mass production. Like here the criticality, maintenance is highly critical. If any one machine is not working, suppose this machine is not working, whole line will come to a standstill, or there is some quality problem here, then also the output of this will come to a 0. So, that is the disadvantage of these flow lines, because they are more tightly connected with each other. Problem at one area will propagate to all other centers, adversely affect all other centers. Then let us look at the process layout. In the process layout, we are grouping together of machines and or workers doing similar task. It is just like this. All A type of processes are kept in one department, all B types of processes are kept at another department, all C types of processes are carried out here, all D types of processes are here. It can be like this from the engineering side. If I look at it, maybe you are keeping all the lathe machines at one place, milling machines at another place, shapers you are keeping at third department, and there can be grinding machines at another department. So, in this case let us say product 1, part 1, it may go from A to B to C to D and then out. There can be another product 2, which may require first C, then B and then D and then out. So, what you are finding, there may be crisscross. Product A is going from B to C, 2 may be going to C to B, and it may not require A also, or there can be different product may have different flow. So, in that case a product layout is not going to be useful for such kind of a work, such kind of a facility where we are having a variety. We are not producing one type of a product, whether we are producing 10 to different types, 15 different types of product, or it can be a job shop system also, just like car service centers, where your different cars are entering into the service facility and each car has a different service requirement. So, in that case also we have to keep a washing area at one side and maybe engine area at another side and body work somewhere else and some other servicing etcetera at somewhere else, and like that, and maybe initial supervisor is coming and booking the orders etcetera at one place. So, in that case we are having a process layout for the job shops or for the services also. So, in the bank also you will find to some extent they are also following the process layout, like you are having a teller for withdrawing cash etcetera, one corner for FD etcetera, you are having one corner for locker etcetera kept at one place, and then for loan etcetera another area is there, another branch is within the branch, another team is looking after that. So, different teams are looking after the different activities, because each person is not requiring all the facilities, one person, one job is requiring certain set of facilities, certain set of processes. So, in that case the machines or equipment or the workstations or the human resource can be very efficiently utilized in this case when the variety is large and volumes are small. Volumes are small, quantity is small and jobs are having a good amount of variety. In that case, the process layout is the most suitable layout. So, we have seen the examples of both manufacturing as well as service systems where process layout is used, very popular layout, and the most of the algorithm, most of the layout planning is also for process layout, because we have seen that for product layout not much efforts are required. You arrange the machines, arrange the departments according to the product requirement, according to the process requirement of the product. But in this case, in the process layout where the variety is large and each product has different set of processes, we have to design in such a manner that the total movement of the man material is minimum and all these man materials are properly integrated. So, the most of the algorithm which we are going to study, they belongs to the process layout. Advantages: there is a flexibility, equipment and personnel can be used wherever they are needed. So, whichever department we can deploy them very easily. So, the utilization is very good, very high. Smaller investment in equipment because duplication is not required. Same machine is used for product A, B, C, D, 1, 2, 3, 4, same set of equipment, same set of facilities are used. Expertise is required, is highly knowledgeable about their function. So, supervisor for each department becomes highly knowledgeable because he is handling several type of jobs, and there is a diversity of tasks can be handled. Changing works make more satisfying, people will feel better because jobs are changing and the job is not monotonous in nature. Every job is a different jobs or a group of jobs you are processing, then there is a change in that. So, in that case the monotony or boredom is less in the case of process layout. In case of batch production, in case of job shop production systems, the boredness is very less and fatigue is also, mental fatigue is less in this case. But obviously, disadvantage wise I am taking it to there also you need more skilled person, whereas in mass production or in a product layout you can have semi skilled or low skilled worker, but for batch production, for job shop production we need highly skilled person, more skilled person, because he has to deal with several different type of jobs. So, let us see the disadvantages of this: lack of process efficiency, backtracking and high material handling. This layout has a lot of backtracking, as we have seen that material is going from B to C, C to B also, and lack of efficiency in timing, and there may be worker has to wait because job is not coming from the previous workstation, or machine may be idle or workstation can be idle, or in between job, maybe job has to wait. There is high work in process inventory in case of process layouts, in case of mass production, in case of batch production and job shop production. They are complex production planning and control, because you have to plan the production planning and control. The major challenges of production planning and control is for batch production system and job shop production system. You have a twin objective. Number one, jobs should not be waiting, as well as machines should not be idle. That means, there should be a good plan, so that at the moment should not be ideal. So, we have to plan in such a manner that the job leaving machine A and going to machine B, at the same time machine B is leaving its previous job and ready to accept the job coming from machine A. So, that kind of synchronization, that kind of planning is required. So, very challenging task as far as production planning and control is concerned for process layouts. Skilled workers and higher wages are there, and lower productivity because of the changeovers. But now we are talking about automation and other thing, where we say that single minute, less than 5 minutes, less than 10 minutes, single minute changeover, less than 10 minutes, single minute means single digit, less than 10 minutes changeover. In that case, productivity may not get adversely affected with computerized CNC machines and other things. You just click the button and there will be change in the program, and you can easily change from one product to another without much cost involved. But obviously, technology in that case is going to be very expensive. Then there is a fixed position layout for manufacturing those products which are non recurring in nature, which are bulky in nature, and like I said that shipbuilding, aeroplanes, flyover, bridges, etc. This fixed position layout is used for those purposes. Here we move the machine and worker to the site, and products normally remain in one location for its entire manufacturing. Advantages are reduced movement of the work item, minimize damage to or moving cost of moving, change in the design etc. can be easily managed, because one set of team is working on the complete job. So, instruction can be given if there is any change in the design or change in product. So, it can be easily accomplished, whereas in case of other product layout and process layout, job is moving and many people are involved at different workstation. If there is any change in the product, each and everyone need to be properly communicated, and his processes etc. also need to be accordingly arranged, changes to be done in the technology machines etc. also, whereas it is easy. But disadvantage is highly skilled person and versatile workers are required. Movement of people and equipment to and from the work site may be very expensive. Equipment utilization may be low, especially heavy equipment like cranes etc. You might have seen at the construction sites etc. Crane is used required for few days, but it has to be kept there for few months also during the project duration of the construction project. So, in that way the utilization of the equipment may be very less. Now, in group technology another kind of feature is used. We will find that there are many jobs, though they are different in nature, but there are certain similarities in them. The similarity can be with respect to the requirement of the processes or process parameters. So, in that case what we do is though they are different, but we take the advantage of some unique similar feature and we arrange them and we group them according to that. So, many jobs have same processing requirement due to similarities in design and or manufacturing, and thus can be grouped to save time and effort. Each group is so formed is called part family. So, we can create a family of the parts which are similar in some manner, and then we can process them together. And this is also called cellular manufacturing. So, once we have grouped the product, suppose you are producing 100 different types of products, for example, say 100 product variety is there. You group them into 10 groups, and then for each group we will create a cell. This is my big factory, and within this I will create the cell for item 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 like this, and in each cell I will arrange the machines according to the process requirement of that job family. So, one family is processed here, another family is processed here, third family may be working, can be done here like this. So, these are called cellular manufacturing, or cells are formed. A bigger factory is broken into cells, and each group is processed in one cell. So, manufacturing or service cells are formed by physical division of the facility. Each cell produces one part family. As I said there, this reduces the waiting time of the jobs. In the process layout we have found. Now, you will find this is a combination of process and product layout. You are having a variety, but you are taking the advantages of flow line. So, within that you are creating a variety is divided into groups, and each group is produced like a flow line. So, that is the beauty of this group technology or cellular layout, where we take the advantage of a flow line for the for a environment where we have to deal with large variety. So, we group them together and perform the same task there. So, this reducing the waiting time of the job in between the processes by exploiting the inherent economy of flow lines, reduced setup time, lower in process inventories, better scheduling, improved tool control and standard process plans. So, in that manner you will get a highly productive system, and you are able to produce a large variety also. But there are the disadvantages also of this system. disadvantage is poor machine utilization, because you may have to duplicate the machine in this cell also. There may be a machine which you are keeping in this cell also, in this cell also, and in this cell also, and the utilization is very less in these cells. If it has been a process layout, maybe one machine would have been sufficient to do that. So, that way if we will see that the machine utilization is poor if the volumes are less, but obviously there are advantages. The production planning and control is very easy, reduced material handling, reduced setup time, reduced tooling, and reduced in process inventory, increased operator expertise, improved human relations also. So, that way we can see that this is very useful concept. Now, let us see the procedure part of it. In the procedure part, it is very obvious also. First thing is we have to list all the departments which I have to lay out, and describe them, how much area is required. We can make a list. Department A 200 square meter is required, department B 300 square meter is required, department C 50 square meter is required, like this. I can say that I need 8 departments A to H, and H required 100 square meter. So, the first step is I must identify how many departments are there and how much area is required for each department, and then I can get the details about what type of facilities I am going to put into that. And then next step is to find out the material movement or personal flow. What is the flow between A and B? How much movement is there between A and B, A and C, A and D, like that. So, I will try to find out how much is the movement, how much is the flow between the various departments. Based on that, I will decide whether they should be kept close to each other or there is no need of keeping them close to each other. Then we will do some algorithm, we will apply some heuristics to obtain a good general layout, and then we will evaluate that layout. Evaluation is generally done on the base of total sum of movement, that is distance into number of trips or number of amount of weight, how many units are moving between the two departments, and summation of all the departments. For all the departments, we will see that what is the difference between the pair of department and how much is the movement between two departments I and J. For all i's and for all j's, we try to see that total load movement between the two departments, and based on that we see that whether layout is good or not. And then if we find that it is we can generate the alternative also, modify it and see whether there is a less movement or there is a increase in movement, and then at the end we select a layout which has the minimum total movement between the departments. And then we also see that machine orientation, storage area and other areas are also accessible. After doing that, then we can put it to the subjective judgment also, subjective arrangements also, that it should be easy to operate in that particular place. Let us see the places where this decision is there. Specification of objectives of the system in terms of output and flexibility. So, we have to see that what is the objective of my layout planning, and what type of output is required in terms of units, in terms of other safety, in terms of material movement and flexibility also. Then estimation of the product or service demand on the system, how much is going to the footfall, how many persons are going to visit to a bank or a airport or like that, or how many products I am going to manufacture. And then the processing requirement in terms of number of operations, amount of flow between department, space requirement for each element of the layout, space availability within the facility. And so, these are some of the inputs we are going to use. What is my objectives, what are the various departments, what is going to be the size of the department depending upon the processes requirement, depending upon the number of persons working there. And then we will convert that information into the any one of these flow metrics or in the form of a relationship diagram. We can use the flow metrics, we can use the flow cost metrics, or we can use the relationship diagram also. So, we will continue from this stage in our next session. There we will learn the various techniques like craft, core lap, LDAP and other techniques also of the layout planning. These are several heuristics which have been developed, and we will find softwares are also available by which we can do the layout planning. Thank you.